So there's a few fundamental things you need to do to check, to confirm that a sprayer is performing properly, and they're the essence of the calibration steps. So one of the first things is to know how fast the tractor is travelling. So you choose a set of engine revs, and you should never trust the tractor speedo. You need to check the travel speed. But the idea of a calibration is that you can actually run at a known kilometres per hour to deliver the appropriate amount of spray. The easiest way to do that is to time the sprayer over a certain distance when it's running up at the operating revs. And you can check that quite easily with a GPS. So you can download a free GPS app for a smartphone and can very quickly check the travel speeds on a sprayer. What's important in setting the engine revs is getting the right PTO speed to deliver a sufficient air from the sprayer for the size of the canopy. And most sprayers on bigger trees are limited in air. So it's quite important to know that you're actually operating the PTO shaft here at 540 RPM. And if you've got a block which has got a range of tree sizes and you don't want to muck around too much with especially different tree types or plant types, it's quite okay to run a PTO at anything between about 440 and 560 RPM, but you really don't want to work too much outside that range or you risk damaging your pump. So 440 PTO will give you less air than 540. And so one way of checking the PTO revs is to trust the readout on the tractor if you've got one. The easiest way to measure PTO speed is to get hold of a non-contact or a contact tachometer. This one's a non-contact tachometer. So it's just a little laser which measures the number of flashes off a reflector. So you can actually mount a reflector on somewhere on the shaft. And on a well-guarded shaft like this, you often have to take it off and put the reflector on the spline itself. And then you can just confirm at what PTO speed you're running. Also very useful for measuring fan speeds and things like that. So, you know, a $40 investment will actually give you a perfectly reliable strobe tachometer. Calibration is all about being able to repeatedly do what the sprayer is designed to do. Is it designed to deliver 900 litres a hectare, in this case 3.2 kilometres an hour? So you've got to have a working tacho on the tractor, you've got to know what gears to run at whatever engine revs. And then when you're running the pump, you actually want to set a pressure which delivers your target output from the nozzles. So most pumps are fitted with a pressure gauge at the pump. It's important to know what the units the pressure gauge is displaying. In this case, it's displaying bar. So 10 bar is 140 psi, is 1000 kPa. And most of the nozzles that we'll be using in a crop like mangoes are probably best operated in a pressure range of between 10 and 25 bar. This is the hollow cone or solid cone type nozzles. If you're using gun type nozzles, the old-fashioned Masotti guns, quite often you have to take them up to 35 bar pressure. But the modern hollow cone ceramics are best operated between about 10 to 20 bar pressure and no lower than about 5 bar. It's important to recognise that the pressure that's displayed to the operator at the pump can be a little bit higher or sometimes significantly higher than the pressure that's actually happening at the nozzles, and the flow rate from the nozzles is determined by the pressure at the nozzle. So in a calibration check, we often just get just a traditional cheap pressure gauge, and we'll put a plumbing fitting onto it which can screw straight onto the nozzle bodies from the sprayer or some other point at the back of the sprayer, and we'll confirm that the operating pressure at the nozzles is what we're looking for and what the gauge is reading when we're running the nozzles at the desired pressure. And quite often it's 2 or 3 bar higher at the gauge at the pump than the pressure at the nozzles. And one of the calibration checks which is important is to see that both sides of the delivery from the sprayer is running at the same pressure, because it doesn't take much of a bit of hose damage or a kink in the line or a change of fittings to see two sides of the sprayer operating at different pressures and giving different outputs. So it's very important to use a cascade of filters. And so most sprayers are fitted with a basket filter, which is a coarsest mesh, and that will filter out the lumps, and particularly things like the rings off the necks of spray bottles and things like that. So it pays to mix your chemical through a basket filter if you can. So more important than the basket filter is the primary filter, which is the suction filter off the pump. It's something that needs to be checked regularly during a spraying operation. Sometimes you have to clean it from tank to tank. You need to clean it at least once a day. It really depends on the spray mix and how concentrated it is. So the suction filter's in here. And the suction filter is the most common place to find a fault in a sprayer in terms of the pump not being able to pick up spray liquid or get up to pressure. It only takes a small leak in the O-ring for the sprayer to start sucking air and for the sprayer not to perform. So the most common fault with sprayers when the pumps aren't working properly is that the O-ring on the suction filter isn't working properly. So they need to be greased, they need to be there, and they need to be accessible to be cleaned regularly by the operator during the spraying rounds. There's three main types of sprayer found in the mango industry. So we've got the air blast type, or the air blast with a conveyor on it like this Radix. We've got the straight throughput fans, and there's an older style of sprayer which is called an air shear, or the Sylvan Turbomizer type sprayer, which produces completely different air. So the straight throughput fans like the Green Tech and the Quantum Mist, which have a small fan directed straight at the canopy, a whole stack of those, and the air blast type sprayer are moving relatively slow velocity, so 20 to 30 meters a second at the outlet, slowing to about 12 meters a second at the canopy. High volumes of air, so anything between about 40 and 60,000 cubic meters of air per hour out of the sprayer per side, directed to the canopy. The other type of sprayer, the air shear type sprayer, is generating very high velocity air, so anything between 100 and 150 meters a second, which is used to actually create the spray droplets by shearing a bleed of liquid in that high velocity air into very fine droplets. The cost of generating high velocity air is it takes a lot of horsepower, and it means that we're quite limited in the air volume that we can deliver out of an air shear sprayer. So where an air blast sprayer largely tries to actually replace the still air in the canopy, so that's the Green Tech, the Quantum, an air blast or the conveyor type sprayers, they're trying to replace the air in the tree with spray laden air. An air shear sprayer, the best it can really hope to do is to place the spray with fine droplets as close as possible to the outside of the tree and let the prevailing winds carry it through the tree. So there's a limit to how much replacement of air you can get with an air shear sprayer, and they've largely been replaced in the market by this more reliable type of air delivery, which uses very reliable types of nozzles which produce fantastic droplet size. So in the past, air shear sprayers have produced good droplet sizes, but at the cost of not enough air. These modern sprayers produce plenty of air, and they produce very good droplet sizes using fine droplet nozzles. On most modern sprayers, we're tending to run fine droplets, which is around 100 micron droplet, producing hollow cone ceramic nozzles these days. If you want to run these sorts of nozzles to produce this very efficient droplet size, you've got to make use of a fine enough pressure filter in line to stop them from blocking. So it's very important that you have a pressure filter which is matched to the nozzle size that you're operating. And the finer the nozzle, the finer the droplet, the finer the mesh and the pressure filter needs to be. So this is a small inline pressure filter. It'll be absolutely fine for this type of setup. But what's important is that people will recognize that they've got them and that they are regularly cleaned and maintained. Just opening the tap clears some of the trash that might accumulate, but realistically you've got to take it apart at the end of each spray day or at the end of each spray round to give it a good clean. And it's important, if you just lubricate this with a bit of grease and a bit of grease on the O-ring, they should only need to be just past hand tight, so they should be easy to undo, easy to drop out, easy to wash. And you need to regularly check the filter elements in them to make sure that they haven't got any holes in them, as in blow through. If they've got large holes in them, they won't be working as effective pressure filters. So the O-ring sits in just behind the thread of so when you unscrew it, the O-ring's just inside there, which is a seal. If it's well lubricated, you don't have to do it up very tight to get it to seal. And quite often the little mesh element that sits in there has a couple of O-rings in it as well. It depends on the design of the pressure filter. But they're a very important investment in modern sprayers. So this sprayer is a Sylvan Radix, and what we're looking at here is some nozzles in a conveyor wing on the bottom of the spray head. So we've got a series of fine droplet hollow cone ceramic nozzles. These are Albus ATR, which is a French nozzle. So it's ceramic inside plastic. They produce an 80-degree output typically, although you can get them now in 60-degree versions as well. And they produce a beautiful fine droplet size, which gives very efficient coverage of leaves and fruit. Most sprayers will come with single or double rollovers so that you can have a high volume and a low volume setup ready to go on the sprayer and turned over at a moment's notice. Sometimes you can even get triple rollovers if you've got complex calibrations to do. They've got a non-drip valve sitting in behind them to stop them dripping when you turn off at the ends of the rows. So this is sort of standard fittings on sprayers these days. If you want to run fine droplet nozzles, they tend to be lower output than our traditional disc and core type nozzles. So having more nozzles available to you in the sprayer than traditional is very important. So in the Sylvan Radic, we have something like 16 nozzles available per side. In the Croplands Quantum Mist, we typically have anything between 24 and 40 nozzles available per side, whilst in your traditional air blasts, it's quite common to only have 10 nozzles available to you. So if you've got a sprayer which is limited in its number of nozzle positions and you want to get into fine droplet spraying, one option is to put an additional nozzle ring into the line so that you can double up the number of nozzles so that you can get into the fine droplet size ranges. Or you can actually buy nozzle bodies which will double up the nozzles. There's a couple of different examples here so that you can actually put, by increasing the number of nozzles available in each position, you can drop your liters per minute per nozzle while keeping the output the same and move from coarse droplets into a fine droplet spectrum, which gives you very efficient coverage, provided your sprayer has the air to deliver that spray to the canopy. So this sprayer is a Sylvan Radic, and it's got a conveyor tower on it. So what that's trying to do is profile the air and allow the operator to adjust the top and bottom profile of the air to match the target canopy. And in hedgerows mangoes, it's a particularly well-suited sprayer for not spraying up into the air where spray can be lost as drift, but to actually target into the tree. And the bottom conveyor on the tower appears to be doing a good job taking spray inside the canopy to spray the far side of the trees on the inside from the opposite row. So the spray fan in here is about 1,000 millimeter diameter, so it's quite a large fan. This is an older fan which has got the aluminium blades. You'll find that most modern sprayers coming out now have a profiled molded plastic blade which is more efficient in its air movement. So there's been a serious evolution in fan design to improve the efficiency, reduce the noise by having smarter design of blades. So we're moving away from aluminium blades to plastic ones. And most of the manufacturers are following suit. So we've got that with the through fans, as in the Xardi fan Croplands and the Green Tech. We've got it in these large air blast fans with or without towers on. So in crops like avocados in particular, where there's quite a lot of leaf litter and mulch, blocking the fan and reducing the air inlet by picking up leaves off the ground is a major issue. And you'll notice that this is an aftermarket leaf restrictor that's been put over the main fan guard, which is quite effective in keeping the fan clear so you get good air input. It's very important to match the amount of air that's coming out of your sprayer to the travel speed that you're trying to deliver the spray at, to the size of the canopy and the density of canopy that you're trying to spray, and to the conditions at the time of spraying. So you've got a whole lot of variables to play with. So how much air is being produced, how fast are you trying to go, how far are you trying to throw it, and where are you trying to throw it to? And it's quite a complicated set of variables, and the best way to see that a sprayer is delivering enough air is to go out and have a look at it operating in the field. Stand on the upwind side of the sprayer if you're operating with a crosswind, and you want to see that the sprayer is pushing at least 1 meter and up to 2 meters past the canopy into the wind in any gaps between the trees. If you open underneath, you want to see a little bit of the spray pushing underneath, and you don't want to see masses of spray going into the air, meters into the air above the canopy. So in a perfect setup, you want to be traveling at a speed that allows the spray-laden air, or the air from the sprayer, to carry the spray to at least 1 meter to 2 meters past the canopy and the gaps into whatever prevailing wind you're spraying in. And if you're not doing it, if you're not able to do it, you either need to increase your fan speed, or you need to slow down, or you need to reconfigure the air output from the sprayer. In the worst case, you actually sometimes need to take the air from both sides of the sprayer and turn it so that it's only delivering from one side, put a volute on, and it gives you the opportunity to push the air up into large trees like avocados and tall mangoes using a single-sided volute. In terms of work rates, it's much better to be able to spray both sides, out of both sides of the sprayer at once. And so you need to be prepared to travel at whatever speed limitation you have to be able to deliver the air, because spraying two sides at once slowly is often a faster spraying proposition than spraying from one side a little bit faster. The majority of air blast fans like this, so this is an air blast fan with a ducted tower on it. Most air blast fans rotate counterclockwise, which means that you've got a lifting effect on the right-hand side of the sprayer looking forward and a dumping effect on the left-hand side. So most modern sprayers have some kind of veining to try and straighten out the air. But there's a real risk that if the sprayer is going to be weak on any side in the wind, it's going to be on the right-hand side with the wind coming towards the sprayer from the right-hand side, and it'll tend to lift and get blown out of the canopy. So again, you've got to match your travel speed to the ability of the spray-laden air to reach the canopy, and if you're looking for weakness, look on the right-hand side. With a tower like this, what the manufacturers have tried to do is use vanes inside the slots to try and even out the air from side to side. And typically with an air blast sprayer, what you see when you measure the air, so I use a little handheld anemometer. You can get Kestrel ones. This is an old Dick Smith one. If you measure the air in the output part of the near the nozzles, what we'd expect to measure with an air blast type sprayer is an output speed of between about 20 and 30 meters per second. And that's typical, and the exit speed of spray from the nozzles is usually in that order as well. For efficient spray coverage, 20 meters a second is too fast. If that's the travel speed of the air when it reaches the canopy, you tend to blow dry that section of the canopy, and the spray doesn't start to deposit well until the air spray interaction at the canopy is traveling at 12 meters a second or less. So typically we have a speed of 20 to 30 meters a second at the outlet. By the time it reaches the canopy, we expect it to have dropped to about 12 meters a second, and we'll see good stalling of the spray within the canopy, good replacement of the still air within the canopy with spray, but good stalling and fallout of the spray within the canopy and very good coverage. If you've got too much air and you're visibly blowing the spray right through the canopy, you can expect to lose about 30% of your total applied volume to the interrow as loss, which could have been applied to the canopy if you've got your air right. And it's all about matching your travel speed to the size and density of the canopy and the distance that you have to throw the spray. What that means is if you're on tighter rows, you can travel usually faster than if you've got the same canopy on wider rows and you've got further to throw the air to get there. Likewise, smaller trees, you can usually travel a little faster or use a little less air than you need on bigger trees. So big, dense trees need more air and need slower travel speeds. When you're spraying efficiently, you've got to match the air outputs to the size of the canopy, because you've got to replace the still air in the tree with spray-laden air, however you do it. So the ideal conditions for spraying is in some crosswind, about 4 to 8 kilometers an hour is usually perfect conditions for spraying, because you do get some movement of the spray droplets through the wind speed. Most sprayers, which are air blast or the straight throughput fans, are moving relatively slow velocity air, so it's 20 to 30 meters a second at the outlet. So 10 meters a second is 36 kilometers an hour, so 30 meters a second, you're looking at about 100 kilometer an hour winds. So the straight through fans like the Quantum Mist or the Green Tech and the air blast type fans are moving air of that nature. If you've got the traditional Sylvan type air shear sprayer or turbomizer, it's a completely different method of spraying where you're generating very high velocity air, typically 100 to 150 meters a second at the nozzles, and you're using that high velocity air to form the spray droplets. The cost of generating air at high velocities is that it takes a lot of horsepower, and so you are quite limited in your air output volumes. And so it becomes quite a different scenario with spraying. And realistically, what we're trying to do is just get the spray into near the canopy and let whatever prevailing wind is there to carry it through the canopy. So they're the most wind-affected sprayers as the air share, and they're tending to disappear from the market to be replaced by these more efficient modern fans with really accurate targeting. The next most important thing is to get your spray output distribution profiled appropriate for the sprayer. So if you've got a sprayer like this with a conveyor on the bottom and a tree like a mango which tends to be somewhat hollow inside, there's an opportunity to put quite a significant proportion of your volume out of this bottom conveyor and spray up into the tree from down low to fill the tree with spray-laden air and to spray the back sides of the far side of the row from the opposite row from the inside. In a more traditional air blast type setup, what you tend to have to do is to put about 60 to 70% of your spray output out of the top third to half of the effective nozzles to spray up into the tree, with the assumption that some of that spray is going to fall out through the canopy after you've gone through. And we always find it pays to bias the output towards the tops of the trees, because the tops are always harder to spray, they're always more wind affected. So whatever you do, you want to actually, however you achieve it, you want to get a greater percentage of your output into the tops of the trees than into the bottoms, unless you've got very inverted trees with very big bottoms on them. So for a typical mango canopy, you're looking to put about 60 to 70% of your total output out of the top half to third of the sprayer into the top half to third of the tree.